Hello, this is my Chapter 2 exam video presentation. So, Chapter 2 exam. Okay, so we're going to start with Part A. You throw a ball straight up from the edge of a cliff. It leaves your hand moving at 12.0. Air resistance can be neglected. Take the positive y direction to be upward and choose y equals 0 to be the point where the ball leaves your hand. Find the ball's position 0.3 seconds after it leaves your hand. Express your answer with appropriate units. So what we're first going to do is just put part A here. So we're going to put part A here, and we're basically just going to just list out some of the items. So the initial velocity of the ball was already given to us, which was equals 12.0 seconds. Okay, and then we're going to do the initial position of the ball. Position of ball, which is right, equals 0 meters. Then we're going to do the time elapsed. Time elapsed, and that equals 0.300s. All of these values were already given to us, so I was just kind of just putting it there just to organize it, to make it cleaner and just clearer. So our next step is we're going to have to use the equation of motion, which could be found in the textbook 2.4, and it's on table 2.5, and it's the second equation in that table. So it's, I'm gonna go ahead and write it down. So it's x equals x0 plus xt plus 1/2 axt squared. So, and also a equals negative g, and since the g goes downwards, and basically what we do from now on, like after I set this down here, we're basically just going to plug in our values. So here we're going to do y equals 0 plus 12 that we got from the problem A times 0.3, which we already got, minus 1/2 times 9.8 times 0.3, which was the time elapsed, squared. So then basically what I'm going to do next is just solve the problem as it is. So let me get my calculator. 0 plus 12.0 times 0.3 minus 1/2 times 9.8 times 0.3 and square root 2. And then for the answer for this, we should get 3.159. When you round it up, you should get the answer, which is y1 equals 3.16 meters. And yep, that's about all it for part A. Let me clear this off. So basically for part A, I just basically kind of just listed out the values that were given, labeled it, used that equation from 2.4 and table 2.5, and just plugged in all my values, and then just solved it the way it was, and that's how I got my answer. So I'm gonna put this right here. So now we're gonna do part B, read that out. State whether the ball is above or below your hand 0.300 seconds after it leaves your hand. Okay, so there's two options they give us. The ball is above your hand, the ball is below your hand. So how I kind of put it as is that since my answer is positive, it has to be above the hand. So I'm just gonna write, since my answer that I got from part A is positive, and it's not negative, positive, then it is above your hand. Now, if it was negative, it would be below your hand, but since I just solved it, it's positive, so it's above the hand. So we're gonna go to part C. Part C. Okay, so just write part C right here. Part C. So find the y component of the ball's velocity 0.300 after it leaves your hand. Express your answer with the appropriate units. So basically, yeah, we're just going to, okay, so first of all, what we're gonna do is, so find the y component of the ball's velocity after it leaves your hand. We're gonna go use that same, like I stated before, table 2.5 in the textbook section 2.4. It has all those equations of motions, which I use for a lot of these problems that help me out a lot. And for that one, we're gonna use the first one. And the first one is written as I think it was Vy equals Vox plus AXT. So this is the very first equation. And what we're basically going to do now is we already have our values from the previous part. So we're basically just going to plug everything in. So V equals 12.0, and then we're going to do plus, then we're going to do negative 9.8, and then we're going to do 0.300. And we're basically going to just solve this right here. Get my calculator. Okay, so 12.0 plus negative 9.8, 0.300. Okay, so yeah, so the answer we got from plugging this in from the equation 1 from table 2.5 and section 2.4, we got 9.06. You round it up, that will equal out to be V1y equals 9.1 seconds. That is your answer for part B. Then I went into tutoring for one of these problems, and basically one of the person said is a lot of those 4 equations you'll be using out the entire course. So I kind of made sure I, understood them and kind of memorized them. They're very important. So for part C, oh no, we just did part C. Bad. For part D, state whether the ball is moving upward or downward 0.3 seconds after it leaves your hand. Okay, so like I said for part B, my answer that I got from solving part C was positive. So it's going in the upward direction. Now, if it was negative, it would go in the downward direction. So I guess I could say my answer is positive. So it is moving in the upward direction. Okay. For D A and B was pretty easy. Okay, so now we're on part E. Part E. Find the ball's position 2.6 seconds after it leaves your hand. Express your answer with the appropriate units. So A, B, C, D, E. Okay, this is part E. So basically, we're going to use that same equation of motion of constant acceleration, which was found in section 2.4, table 2.5. And the equation we're going to use for this one is, I believe it's the second equation. So I'm just going to go ahead and write that out. X equals XO plus VOXT plus 1/2 AXT squared. Then we're going to find the ball's position. So find the ball's position. Okay, yeah. So we're just going to plug in our values that we already got. So here I can go ahead and just like kind of write out the values. I don't think I did that for C or B, but I'll do it right here to make it more clear. So XO is going to equal 12.0, and then 2.60, 2.60 equal X. Okay, yeah. 2.6 will equal T. Equal T. And then 2.6, yeah, because seconds. And then, yeah, so basically we got that. So X equals 12.0. Then multiply that by 2.6, which was already given to us, which is, T equals 2.6 seconds, plus, so basically what I'm doing, I'm just going from this equation right here, and then just kind of just plugging it in, plus 1/2, then, so AX will, oh yeah, we do it. AX equals negative 9.8 squared, so it'll be negative 9.8, and then 2.6 would be squared due to the formula. 2.6 would be squared, and then I'm just going to solve this on my calculator. So 12.0, so 12.0, 2.60 plus 1/2, plus 1/2, is that negative 9.8, negative 9.8, then 2.60 squared. Okay, yeah. So after plugging all this in, we will get y2 equals negative 1.924, round, do the square root. I mean, not the square root, round the number, my bad, equals y2 equals negative 1.9 meters. And this is your answer for part E. And that's how I got it. Now, part E. So we're gonna go to part F. State whether the ball is above or below your hand 2.6 seconds after it leaves your hand. So like I said in the previous problems, if my answer, how I kind of thought about this, and I kind of got this from tutoring, I think like probably a week ago when I was working on the homework, if your answer is positive, most likely it's going to be above or moving upwards. So due to that, in part E, I'm just going to say that it's the ball is moving below your hand. So I'm going to say the ball is moving below your hand due to due to y2, or my answer in part E being negative due to my answer being negative. Okay, now we're on part G. I'm in part G. So we're going to find the y component of the ball's velocity 2.6 seconds after it leaves your hand. Express your answer with the appropriate units. So the velocity is already given to us, which is 2.6 seconds. So with that being said, we're going to use the first equation of motion constant acceleration from and also that one, the first motion equation of constant acceleration was also in 2.8, but you can find it in 2.4 and the table 2.5, and it's the first equation. So yeah, so let me just go ahead and just write it out for you. So okay, yeah, so it's Vx equals Vox plus AXT. So okay, so basically I guess I can make it cleaner like this. So Vox will equal 12 seconds. Okay, yeah. So, and then AX will equal negative. Just a sign. Be 9.8, and then the T, on which we already know from the previous problems, is 2.6 seconds. So basically, we're just gonna plug these values in, and yeah, solve it. So we're gonna get V equals 12.0 seconds plus 9.8 milliseconds squared and multiply by 2.60. All right, so we're gonna get 12.0 plus 9.8, or actually no, let me put that in parentheses, 9.8, 2.60. Hold on. Or was it, wait, hold on. I'm just trying to solve this out real quick. Plus, okay. So I kind of made a mistake. So this 9.8 is negative, and it's going to be negative in here. So when we solve that, when we solve this, it'll come out to be negative 13.48. That's going to be your answer. Round it up, so it'll be negative 13.5. So it'll be V2y equals negative 13.5. Yeah, I made a simple mistake. I don't know why I put negative 9.8 as a positive, because it kind of messed up the whole equation. The whole problem. So now we're going to go to part I. Oh no, not part I. We're going to go to part H. My bad. Part H. Part H states, state whether the ball is moving upward or downward 2.6 seconds after it leaves your hand. So, like I said, like previously, if your answer that you get is positive, then it's going to move either upward or above your hand. And since my answer is negative, it's going to be, the ball is moving downward in a downward direction. So say the ball is moving downward. Okay, the ball is moving downward since it's negative. Kind of put a line out to split apart. So now we're on to I. This is part I. Okay, so let me just go ahead and write part I real quick. Okay, here, this right here, parentheses. So you throw a stone straight down from the top of a tall tower. It leaves your hand moving at 8 milliseconds. A resistance can be neglected. Take the positive y direction to be upward and choose y equals 0 to be the point where the stone leaves your hand. Find the stone's position 1.5 seconds after it leaves your hand. So we have to find the stone's position after it leaves your hand. So with that being said, stone's position. Okay, yeah, so we can use the second equation of motion. So we can use the second equation of motion, and this is also, I believe, was in example 2.7 in the video example, because when I watched that and I saw how he kind of kept using one of those 4 equations from section 2.4. And so you can use, the second equation of motion with constant acceleration. So that would be x equals x, wait, did I already write that down before? Wait, x equals second equation of motion. So x equals xo plus voxt plus 1/2 axt squared. This is from table 2.5. So u is moving. Leaves your hand moving. Okay, so the initial velocity of the stone was of the stone is -8. So I'm just gonna put initial velocity is -8.00 seconds. So basically, with that being said, we're just gonna plug everything into this equation. So we're gonna get y equals -8.00, and then we already have the seconds, which was 1.50, and we already have the seconds. It was 1.50, and then minus 1/2 9.8 over 1.50 seconds. So we're actually going to plug, we already just plugged in. We're just going to solve this. I'm just solving this on my calculator. 1.50 minus okay, so that's what we got. Okay, so after solving all of this, you get y1 equals -23.0. I rounded it up. My original answer was -23.025, but I didn't round it up. I just So that's your answer. And then so now we're going to go to part J. So you find the y component of the stone's velocity 1.5 seconds after it leaves your hand. Express your answer with appropriate units. So basically, to find the y component of the stone's velocity after you leave your hand, you would use the first equation of motion, constant acceleration. Those 4 important problems that I think that we'll be using throughout the course. And I'll go ahead and write it down. So Vy equals Voy plus Ayt. AYT. And also this is from 2.8 to, no, just 2.8. And then, okay, so we're just gonna plug everything. First, we're gonna just kind of make it neat. So VOY would equal -8. AY would equal, AY would equal, yeah, AY would equal -9.8, and then T for seconds would equal what was already given to us is 1.50. So we're just gonna basically just kind of plug these things in right here. So we're gonna get VY equals -8 plus -9.8, 1.50. Let me solve this with my calculator. So -8 plus 9.8, 1.50. Okay, yeah, so what our answer will be -22.7. So -22.7 squared, and that will be V1Y. So V1Y, and then, okay, so that'll be your answer. Now we're going to go to part K. Part K, it says, find the y component of the stone's velocity when it's 8 meters below your hand. So 8 meters below your hand. Okay, so 8 meters below, 8 meters below. Okay, yeah, so what's this part K? And yeah, so I already know what we're gonna use, because just by the way the problem is telling me. We're gonna use the third equation of constant acceleration. The third equation from the equation of motion, constant acceleration from 2.4. And with this, here I'll write it down. So it'll be third equation is like Vy squared equals Voy squared plus 2ay. And with this, so yeah, so basically, I'm gonna make it cleaner. I'm also gonna do Voy squared will equal to -8, and then ay would equal, no, a would equal -9.8, I think. Yeah, -9.8, and then y would equal -8. Okay, so we're gonna just plug this in. So Vy squared equals -8 squared plus 2, which we got from right here, then -9.8. Okay, yeah, so and -8. So then we should solve this and we should get the answer. 0.8 plus 2, -9.8, -8. -8. So negative. I'm just seeing what I got wrong in this one right here, because I was getting the wrong answer from what I usually get. Okay, yeah. So 14.9. So V2Y will equal 14.9 milliseconds. So then that's for part K. So we're going down to part L. So with part L, you throw a football straight up, air resistance can be neglected. When the football is 4 meters above where it left your hand, it is moving upward at 0.5 milliseconds. What was the speed of the football when it left your hand? Expect your answer with appropriate units. So, okay, yeah, so we could basically, this was the third one. So we can basically use the same exact equation that we did for part K. So, which would be, so I could say, V y equals V O y squared plus 2ay, and then, x equals x0 y. Okay, so I got this from table 2.5. So we already have pretty much the values already given to us, so we can just plug them in. So it'd be 0.5 squared equals VOY squared plus 2 negative 9.8 times 4. And with that, we're just going to solve this right here. So I'm just going to go ahead and do it. So 0.5 squared, that'll be 0.25. And then that'll equal VOY squared plus, 78.44. And then, okay, yeah, so then VOY squared equals, we're going to rearrange it, 0.25 minus 78.4. And, okay, so yeah, so VOY equals negative 78.65. Square this, and then okay, yeah, so then our answer, square root of that would be 8.8 equals 8.87 milliseconds. And that was VO. So that's your answer right there. Okay, so we're on part M. So part M of the equations. So part M, how much time elapses from when the football leaves your hand until it is 4 meters above your hand? So to figure out the time elapses, we would use the first equation of motion, and with that was also from the 2.8 textbook, and I believe this was from the example 2, what was it, example 2.4, I believe, or was it example 2.8? It was the example 2.8, and with this, basically going to do, so Vx equals Vox plus Axt. And then, so basically how this one's going to work is that we're going to use the answers from the numbers from our previous problems. So 0.5, which got from our previous problems, equals, and the answer that we just got, 8.87 minus 9.8t. Then we're gonna kind of just flip it over here. So 8.87 equals 9.8t. No, that's minus. Yeah, what am I doing? Because we just flipped it. Equals 0.5. And then 7 to the negative 9.8 t equals negative 8.368. And then we're going to turn this into a fraction. So it'll be t equals negative 8.368. And then be negative 9.800. Just added the extra zeros just to kind of even it out. Then solve for this. Let me just get my calculator real quick. Okay, so yeah, so we got 0 points, so equals 0.85. Yeah, 0 points. Okay, yeah. 0.854. So t equals 0.854 seconds. So that's for part M. Scroll down to part N. So for part N, you throw a tennis ball straight up. Air resistance can be neglected. The maximum height above your hand that the ball reaches is h. At which speed does the ball leave your hand? Express your answer in terms of acceleration due to gravity and the variable. So, okay. So with this, we're going to use the third equation of motion. And that's in the textbook also in 2.13. And yeah. So I'm going to go ahead and write it out. I like writing the equations out first because it kind of just like simplifies my mind real quick, so I know what to do. And then 2ax over x minus x0. So okay, so I know 0 squared is going to be like that, and then VOX squared plus 2AGH. So basically, I was just plugging things in from the problem that was presented, and here. Yeah. So then we're basically just going to simplify it from here. 2GH. Let's see if I can remember that. Okay, so V squared 2GH, and set this equal to 0. And then now equal 2GH squared root. Okay, so VO equals 2GH. This one, at first, I kind of had trouble with it because just how to attack it. But like I said, when you kind of memorize the formulas, those 4 formulas, equation of motion, constant acceleration, the rest of these problems become a lot easier to solve. And which is why I kind of forced myself to memorize all these formulas before I even did the homework at all, because I knew these would probably show up in the homework. And I'm glad I did because it helped a lot. So part N, so we're in part O. So what is the speed of the ball when the height is h over 2 above your hand? Express your answer. Okay. So same thing, we're going to use the third equation of motion, which is like this one right here. 3x2 equals VOX2 plus 2ax x minus xo. Okay. And this one, basically doing the same thing as part N, but we're trying to find the height above your hand. So we're gonna kind of like plug things in. So x2 equals 2GH, which we got from the previous problem, and then minus GH. Actually, no. Let me restart. I'm just going too far ahead. So okay, so VOX2, okay, minus 2GH squared. Okay, and this was given to us already. And basically we're just going to simplify everything. Square equals 2GH minus GH. Then we're going to get VX squared equals GH. And then that would turn square root. So VX equals GH. Okay. So now we got, so over here, so we got VX over VO, right? So then we're going to take this right here, put this on top, GH, and then the answer from our previous problem, which that would be 2GH. And basically we will solve this, and you would get, I can already tell, you would get so 2GH. Yeah, so this would cancel out, this would cancel, this would cancel out. So we 1. So you'll get 1 over -2. I mean, not -2, square root of 2. And then I don't really need to use my calculator for this one because I can already, so it'll be 0.71. So the answer would be VH equals 0.71 VO. And that would be your answer. I'll just kind of make sure you can see it. Right, so now we're going to part P, which is the last one. So with part P, at what height above your hand is the speed of the ball half as great when it left your hand? Express your answer in terms of h. So like I said in the previous ones, we're going to use the same exact third equation of motion. Equation of motion, constant acceleration, and yeah, and this is from table 2.5. So we're going to do the Vx squared equals Vox squared plus 2ax over x minus xo. Okay, and so we're going to do Vo over 2 squared equals Vox squared plus 2ax. And then minus, this will be VO2 over 4 equals VO squared plus 2ax. And then we're going to set this into a fraction. So y equals VO2 over 4 minus VO2, 2a. Then we're going to solve this right here. Okay, yeah. So negative VO2, 8a, and then it's going to be -3, 2gh, 8g, and then simplify this right here, and it will get us to be 3h over 4, and then that would be our answer. So h equals 3h over 4, and that is for part P. So I finished it. Basically, with a lot of these problems was me being able to memorize the 4 equations, and what really kind of like helped me memorize those 4 equations was I was in the tutoring lab speaking to an individual, and they're basically saying like these 4 equations is what are going to be used pretty much throughout the course. So it's better to like have them memorized. So I kind of just opened up a Quizlet, kind of just kept like, you know, drilling, memorizing them and like understanding them and stuff like that. And also when to use them too, because I feel like that's also important. instead of just memorizing like the actual equation. And yeah, and I was able to solve all of these pretty well. And I'm trying to think if there's anything else. I referenced the book several times, the section of where you find the equations, and I modeled the way the book modeled it too. I modeled the way the book solved the equations too. I'm trying to think if there's anything else. Yeah, and I think that's about all it. And yeah.